Some of you all here, right? Okay, good. Right. So remember lastly, when we started, we talked about trigs and we kind of showed some of the things that that you should know about trigs in Unit 1, right? From ADMAS, sorry. Some of the things that we were saying were this. If you had a graph between 0 and 2 pi, right? Let's say you had to find sine 2 theta is a half between 0 and 2 pi. We said that if you draw a half, draw a line, you would recognize that you have 1, 2, 3, 4 solutions. That's okay? And I showed you how to get your 4 solutions. You find sine inverse of a half, right? When you find sine inverse of a half, you add 2 pi to your values. That's okay? Right. Suppose it was 3 theta or 4 theta or 5 theta. Remember what's happened? You end up with 2 more values each time, right? Remember that? Yeah? If it was sine theta was 2 values, for 2 theta, 4 values, and so on, right? Right. So the problem is now, when the value for theta gets large, let's say k, then the number of solutions become large, right? Are you okay with that? So what we need to get now is something called a general solution. You don't want to have to work that out. You don't want to have to keep working out 10, 12, 13 values, right? So what you have is something called a general solution. So whenever you're solving cos and sine and tan, there's a general solution for each one of them. All right? So therefore you don't have to run work out all. Okay? So head up general solution. This is something new. So head up general solution. So let's say I ask you to find the general solution for sine k theta is equal to c. Okay? Then you would write k theta is equal to sine inverse c, and then proceed to work out the values, right? So here's what the general solution will look like. The general solution looks like this. K theta is equal to 2, this one is n. N by pi, n means any number of solutions you need. N by pi plus minus 1 to the n by alpha, where alpha is equal to sine inverse c. Right? If you want to make it look even nicer, you could say theta is equal to n pi plus minus 1 to the n alpha all over k. Right? That is your general solution, and I want to show you how to use it. Right? That will give you any solution you need in for sine. Ready? Right, so all right. So let's find, so example 1, find the general solution of, let's see, we got 2 sine 3 theta is equal to root 2. Okay? So basically, carry across the 2, carry across the sine, and you will get 3 theta is equal to sine inverse root 2 on 2. Right? So the general solution is this. 3 theta is equal to 2n pi plus minus 1 to the n of alpha. Right? So you have to work out alpha. Alpha is sine inverse root 2 and 2. How much you got? How much you got there? Pi on 2? Sine inverse root 2 and 2. There's no pi on 4? Pi on 4, right? Right, yeah. Pi on 4. I can make sure. 3 pi on 4. So this is your general solution. If you want to make it look nicer, divide by 3, and you will get 2 on 3 n pi plus minus 1 to the n pi on 12. That's a general solution. So for example, if you want the first solution, put n as 1. And you'll get your first solution. Try it and see. Put n as 1. You will get theta is equal to 2/3 pi minus pi on 12. How much is that? That is 488 minus. Yeah. No, sorry. 8 minus 3, 5 pi on 12. Anybody get that? 5 pi on 12. Just check it and see if n is 1. Yeah, you all got 5 pi on 12 there? Or you lost? Or you lost? Yeah? So you say yeah. So she brave to say yeah. Right. So here's what we're trying to do. We're trying to come up with a formula that can help us find any angle, any solution, right? Let's pretend we didn't have this. What you would have done here, you would have said, well, here's what 3 theta is equal to sine inverse root 2 on 2. You'll get 3 theta is sine inverse root 2 on 2 is pi on 4. Right? When you carry across the 3, you will end up with pi on 12. So that is one of your solutions. Correct? And that's what you'll normally do. Sarah? And you'll also get your next solution for sine is when? Pi minus pi on 4, which is 3/4 pi. Correct? So you multiply that by, sorry, you divide that by 3, so you'll get 3 pi on 12. That's okay? So we're supposed to begin those solutions now if I come back here and use this formula. Right? So let's see. let's see what will happen. So this formula is a general solution that'll give me anything. Okay? Are you okay with that? So let's put n as 1 and see if we could get the first thing. We get in 3 theta, right? 3 theta is equal to 2 by 1, which is 2 pi, plus minus 1 to the power of 1 by pi on 4. So 3 theta is equal to 2 pi minus pi on 4. 2 pi minus pi on 4 is 7 pi. 7 pi on 4. Divide everything by 3, and we get in 7 pi on 12. Oh, okay. Oh, the last time I wrote it? Yeah. Last time I wrote it. Okay. So that is your value. That's one of your values, 7 pi on 12, right? Right? Also, when n is 0, I left out that one. When n is 0, you will get 3 on 2 by 0 pi plus minus 1 to the 0 pi on 12. This is 0, and then to the power 0 is 1, so you'll get your first solution, pi on 12. That's okay? So this pi on 12 coincides with the first value. So this formula here in the box supposed to give us all the angles. I'm not sure why I'm not getting the 3 pi on 12. We'll try back the next one and see the multiply wrong. So you see why what the formula gives you now, Sarah? Right? The formula allows you to get any of these angles. So instead of going to have to work it out, just use this formula. Say again, 3 pi on 4 divided by 3 is pi on 4, or 3 pi on 12. Check the calculator answer. Huh? How much you got? 3 pi on 12 divided by 4. 3 pi on 4 divided by 3. Huh? How much you get?
Oh, so then why didn't
Same thing, Shirish. All right? All right. So that is the purpose of a general solution, right? Of course, I kind of jumble it up here, but all you're doing is stopping right here. When I say give a general solution, you're stopping right here. So try this one here for me. Sine theta is equal to a half. Try that, please. Huh? N pi. I wrote the wrong thing. Oh, that's why. I don't know why I get the wrong answer. N pi. Right here. Sorry. Thanks, Sam. All right. So I wrote it right the first time? Right. Yes, I wrote it right the first time. This is the formula. I apologize earlier. Making real mistakes today. Right? That's the formula we're using. Okay? That's why it wasn't working out the first time. Try this one here for now. Find the general solution for sine theta is equal to a half. right? So you would have theta so you would get theta is equal to sine inverse a half. So the general solution is n pi plus minus 1 to the n of alpha. Remember, alpha is equal to sine inverse a half, which is pi on 6. That's okay? Pi on 6. So that will be pi on 6 here. Right? When you put n as 0, that'll be like your first solution. So you'll get theta is pi on 6. When you put n as 1, you'll get pi minus pi on 6. Okay, so it's working nicely now. Right? I made a mistake the first time. That's okay? And as you keep putting n, you'll get any amount of solutions you need. Okay? Everybody okay with that? Let's try one more for the road there. Try sine 2 theta is root 3 on 2. Work it out fast. Shishivish, how you work it out? Finish? So you'll get 2 theta is equal to n pi plus minus 1. We had to find alpha. Alpha is equal to sine inverse root 3 on 2. So that was pi on 3. So you put pi on 3 here. That's okay? So that's the way you use general solution. When they say general solution, don't work out anything. Just use the formula. Okay? Are you okay with that? Right? There's a general solution also for cos and sine. Cos and tan. Any questions online, Emily? Are you okay there? Hey, look, Rihanna. Rihanna, that's you there? Are you okay with that? Right? So for cos p theta is equal to C and for tan p theta is equal to C. Here, the general solution is k theta is equal to 2n pi plus and minus alpha. Alpha is cosine inverse C. right? And the general, again, if you want, you can divide everything by k, right? 2n pi plus and minus k plus or minus alpha. You can divide everything by k if you want. Right? And the next one is n theta is equal to, this one is n by pi plus alpha. So the previous one, how I got pi on 3, just now check back for you there. Right, please notice for all of them that we could take alpha between minus pi on 2 and pi on 2. So we could take alpha for all of them within this boundary, right? Right, will you ask just now again? For the last one, that's this one here. What was sine inverse root 3 on 2? Pi on 3, yeah. This is the square root of 3 on 2, eh? Check it back at Phoenicia. Just check it back and see. I got pi on 3 for sine inverse root 3 on 2. Yeah? Okay. All right, everybody have this? So those are your two general solutions, right? And I gave you the one from before. Yeah, the ranges for all of them, right? Try this one here. General solution for tan 3 theta is equal to 1. And then let's complicate it a little bit. Cos theta minus pi on 3 is equal to a half. Thank you. Anybody got that? For the general solution for 3 theta equal to 1, tan theta equal to 1. Next one. Theta minus pi on 3 is a little bit different, right? But leave the part in the bracket right there and make it equal to the general solution, right? Which is 2n pi plus and minus cosine inverse a half. So that will give you theta minus pi on 3 is equal to 2n pi plus and minus a half is what? Pi on 3? Pi on 3, right? And then carry it across. Carry it across. How you would simplify this? How you would simplify this one? Right? If you want to simplify it, one of the options is to write this. 2n pi plus pi on 3 plus pi on 3. 2n pi plus 2/3 pi. That's one option. And with the minus now. So it will be 2n pi minus pi on 3 plus pi on 3. So that will cancel off. Okay? So if you want to write it, if you don't want to leave it like this, you can write it like this and theta plus 2n pi. Okay? You don't have to. Sorry about the pen, I don't know what happened down there. Okay? You can write it like that, but those are your two possible set of solutions. What was the general solution? 2n pi for cos, right? Plus and minus alpha. That was for cos. All right, so those are your general solutions and how to use them, right? Are you okay with that? So every time you see general solution, write the formula, right? And just make sure you get alpha correct. Okay. Right. So that's one of the new things that we need to learn. So the first new thing that we learned last week, we learned about cosec, we learned about sec, we learned about cot. That's okay. The next thing that we're going to learn, we learned general formula today, general solution. Right? The next thing that we're going to learn is we're going to learn to express r sine theta plus, let's use a and b instead. A sine theta plus b cos theta is equal to some constant c. We're going to express it in the form r sine theta plus alpha is equal to c. The reason for that is this. Suppose I said solve 2 sine theta plus 3 cos theta is equal to 4. How are you going to solve that? for us to solve, normally we need to get one identity, one trig function alone, right? But we have sine and cos. Is there any rule to replace sine theta? Is there any identity to replace sine theta? No. Or cos theta? No. Unless you say cos theta is the square root of. But you can see the problem there. We have a square root to work with. So you wouldn't really use that. So now we need to find a way to solve questions like this. This actually is one of the more popular type of questions that you will see. You need to be able to write it in that form. So if I take this now and write it in this form, I can solve it. Reason being, I have one function, one trig function, sine alone. That's okay? All right, so we are going to learn to do that now. Right? But to do it, we need to remember one rule from Form 5. We need to remember sine theta plus alpha. That is sine theta cos alpha plus sine theta sine alpha cos theta. That's okay? We're going to use that to help us work everything out. Okay? So here's how we do it. So, to get the R is simple. R is the square root of a squared plus b squared. Okay? That's all. To get R, all we have to do is find the square root of a squared plus b squared. Okay? So all we have to do is to figure out how to get R. R is the problem, and alpha is the problem. Right? And I'll show you how to get alpha. To get alpha, all we have to do is to compare R sine theta plus alpha to A sine theta plus B cos theta. All we have to do is compare it. Okay? If I were to expand out that R sine theta plus alpha, I will end up with R sine theta cos alpha plus R sine alpha cos theta is equal to this long thing here. Are you okay with that? Just take it in for now. I want to make sure you understand, and now let you write it down, right? You understand what I'm trying to do there? Sarah? So we already figured out, so I'm trying to get the two blue question marks. I'm trying to get R and trying to get C. R real simple. R is the square. Excuse me. Just take it in here and let's make sure it makes sense, right? R is square root of a squared plus b squared. So now we're trying to figure out how to get alpha. In order to get alpha, I am going to compare this here to this here. Because remember, I want to make this and this equal. Correct? I want to make two of them equal, so I should be able to compare them, right? Everybody okay with that? So I'm going to compare them now and see if they can help me find alpha. Right? So what you see? Whatever in front of cos theta, that's P, right? So therefore, this should be equal to B. Correct? Y'all seen it there? Hey, John, you seen it? You not seen it? Right. So these two things have to be equal. You okay with that? Right. So whatever in front of cos theta, and it must be plus B. What you have in front of cos theta here? And positive R sine alpha. So therefore, those two things must be equal. Correct? So now we could say, well, here's what? R sine alpha is equal to B. So it means that alpha is sine inverse B over R. Correct? That's it, right? Or you can come on the next side and say, well, whatever in front of A, whatever in front of sine theta is A. So that's this by this. You'll get the same answer. Or some textbooks, they went even further and they say, well, here's what. Tan alpha is equal to B on E. How do they get that? Well, they took R sine alpha and they divided by R cos alpha. And you end up with B on E. The R's cancel and tan and sine and cos tan. Okay? Some books you will see that same answer. It don't matter which one you use, you're gonna get the same thing. That's okay? So that is the way to convert this to this. You find R, then you find alpha. Okay? Copy it down and then we're gonna put some numbers into it and make a little more sense. All right? Copy it down. Copy it down and we're going to try one. That's right? Yeah? All right, let's go. Express 3 sine theta plus 4 cos theta in the form R. Right, let me just squeeze it in there. In the form R sine theta plus alpha. Okay. So let's do it together. A is how much? A is 3 and B is 4, right? So we could easily find R. R is the square root of 3 squared plus 4 squared. All okay with that? So that should be 5. Right? Now we're going to compare both of them. So we're going to create 3 sine theta plus 4 cos theta to r sine theta cos alpha plus r sine alpha cos theta. Okay, so we're going to compare. To satisfy your mind, you could do any one you want, right? I am going to do r sine alpha is 4. So when I compare, I got r sine alpha is equal to 4. So therefore, alpha is equal to sine inverse 4 on r, which is 4 on 5, right? I didn't specify if it's degrees or radians, but leave it in radians. Okay, I forgot to say that alpha is in radians, right? Sine inverse 4 on 5 is how much? How much? 0.927. Just for check-in purposes, try r cos alpha is equal to 3. See how much you got? You're supposed to get 0.927. Or you could even use tan alpha is equal to 4 on 3. Alpha is equal to tan inverse 4 on 3. You don't have to do all of them. Huh? I am just showing you to state that no matter, you're supposed to get the same thing. Think about it. What do you think that is? Probably sad. You all recognize that they all give the same value, right? So you can pick any method you want. Okay? Right? So therefore, the final answer is r sine theta plus 0.927. Everybody okay with that? Everybody okay with that? Scarlett? You okay with that? Scarlett, I want to just challenge you a little bit there. Sorry about that, right? Suppose I said I would like the general solution of 5 sine theta plus 0.927 equal to, I'm just making up something, 0.4. What you'll do? Yeah, if you had a guess. Suppose I want the general solution. So you're using the general solution for which function? Sine. What will alpha be? By just watching it there. Alpha be what? Sine inverse of. Very good. Right? And then you go ahead and make theta the subject. All okay with that? You sure? So let me just ask Kaylin now. Kaylin, suppose I didn't put the 0.4 there. I had the 0.4 here. How you would solve that? I want the general solution of that. What the first thing you will do if I give you a question like this? Right, put it in the form and then use the general solution formula. Are you okay with that? Right? So that's what we're gonna make it do now. Okay? That's what the past paper will ask you. Find the general solution of that, and you have to figure out, you gotta put it in this form and thing, right? Right, but there are other forms as well. I'll explain it in a little while. Right? I'll explain all in a little while, right? So I want you to solve this here for now. Ready? Taking this off, right? I would like you to find the general solution find the general solution of 2 sine theta plus 5 cos theta is equal to, I'll use what they have here. What they have here, square root of 29 over 2. So step 1, express in the form r sine theta plus alpha. Step 2, right, use general solution to solve r sine theta plus alpha is equal to root 29 on 2. That's the square root of 29 on 2. All right, take a 2 minutes and try this. So we have r, right? 2 squared plus 5 squared, so that's root 29. Oh, that's what they gave root 29. Oh, that was clever. Right, alpha. It's up to you. You could write it and compare it. Or anyway, it's a good habit to compare it. Today we remember it, but it's a good habit to compare it. Right, so 2 sine theta plus 5 cos theta is equal to r sine theta cos alpha plus r sine alpha cos theta. Right, so using this equal to this, r sine alpha is equal to 5. So alpha sine inverse 5 over root 29. How much was that? 1.1190. I can leave it like that. 1.19, right? I'll leave it like that. So therefore, we end up with root 29 sine theta plus 1.19 equal to root 29 on 2. Okay? So next step, carry across the root 29. So you'll get sine theta plus 1.19 is equal to half. If you divide everything by root 29. Are you okay with that? Anybody confused there? Yeah? Should we be confused? For now. How about what?
I don't know why you're doing last. By next side, brackets to the first one.
Why make it equal?
Equal to.
Because that's what we're trying to solve. So I wrote this in the form and then I make it equal to root 29 on 2.
5 cos theta is actually or sine alpha. So that 5 cos theta is 1 plus 5 cos theta is equal to
5 plus.
and then we're finding out this.
Yeah, plug it in and then you make it equal to root 29 on 2. So when you work it out, you'll get. So when you work it out now, remember general solution at what we're trying to get, right? The general solution is theta plus 1.19, right? General solution for sine, right? So that will be n pi plus minus 1 to the n alpha. Alpha is sine inverse a half. Sine inverse a half, which is pi on 6. Okay? So that'll be theta plus 1.19 is n pi plus minus 1 to the n pi on 6. If you want, you can move across. You can move across 1.19 if you want. You can leave a solution like that as well. Right? If you want, you could also write this, right? Well, okay with that? Killing. What was hard? It was the show. Any questions online? But let's be sure because now all the time. Huh? Yeah. But it doesn't always come in that form. That's why I will show you why I would always expand it. Sometimes we had to figure out the form. Ready? Let's try one more, right? And then I will add on something else. How again? What we're trying to do in the first part. We're trying to write this like this. So we figure out R and we figure out alpha. So you gotta put it back in here. And then that'll be equal to whatever you have here. Huh? We're just trying to simplify. Light boy. All right, next one. Let's try one more like this. Try that, please. Hmm? Yeah. All the best. Sorry? Hmm? Oh, okay. Solve that, please. 3 cos theta plus 4 sin theta 2. Or sine inverse 4 and 5 again. Sorry. I wanted to show you something here. That's why I flip it around. So you would recognize here now that 3 cos theta plus 4 sine theta, if you use the same expansion, will be r sine theta cos alpha plus r sine alpha cos theta. So as we said, when we compare, whatever in front of cos theta is r sine alpha. So that's 3. R sine alpha was 3. You'll see that? So it was a little bit different. It wasn't this value here, right? Okay, it's whatever in front of cos. So that means that alpha is equal to sine inverse 3 over 5. How much is that? How much? 0.64. Yeah, 0.64. So therefore R sine theta plus 0.64 is equal to 2. You finished the general solution part already? Okay. So that means that theta plus 0.64 is equal to n pi plus and minus n pi plus minus 1 to the n sine inverse 2/5. So that's n pi plus minus 1 to the n. What is sine inverse 2/5 again? 0.412 minus 0.64. Okay? That's a general solution there. Adrian, you still getting in trouble? All right, I'll go through the next one with you, right? Right. But here's what I told you. Notice we keep putting it in the form r sine theta plus alpha. Sometimes it's changing, or sometimes you have to change it. Okay? So I want to show you how to figure out which one to use. Right? While you're waiting on Shivi to finish it. So finish. Suppose I gave you something like this instead. Suppose instead I gave you 5 cos theta minus 3 sine theta. Right? That minus sign in the middle there is going to cause a problem. Okay? If we wanted to expand, let's say we expand r sine theta plus alpha. What will happen? You will end up with r sine theta cos alpha plus r sine alpha cos theta. So whatever in front of r sine alpha is 5. That looking okay? What's the problem here? What in front of sine theta is your r cos alpha. So you have a minus sign there. So when you're comparing and not really lining up properly. You're seeing that? Yeah, that minus sign will cause a problem. So in a case like this, we have to change the expansion. We have to change the expansion. All right? So suppose instead, what you see. Suppose instead we expand r cos theta plus alpha. What will happen? You'll get r cos theta cos alpha minus r sine theta sine alpha. So whatever in front of cos theta is 5, so that's this, try this. So it means that r cos alpha is 5. Whatever in front of sine theta is 3. So you're getting R sine alpha is 3. You'll see that? And the signs here matching up, so we don't have to worry about a negative sign. Is that okay with that? So what does that lead to? Well, that leads to this. Right? That leads to this. If we have a cosine theta, if we have r sine theta plus a cos theta, then the best expression to use will be r sine theta plus alpha. If we have it the other way around, I'm not saying the first one can't work, but the best one that will line up nicely is cos theta minus alpha. If on the other hand you had a sine theta minus b cos theta, then the best identity here to use will be r sine theta minus alpha. If on the other hand it was a cos theta minus b sine theta, then the best identity to use is r cos theta plus alpha, right? So some questions, they don't give you a hint on which one to choose. Some questions will tell you, put it in this form and then work it out. If they don't give you, learn the above. Okay. Oh, thanks. Okay. So you can learn those. But of course, you can kind of watch it and figure it out, right? You can watch it and figure it out. Yeah, you can just write it down and learn it. You could, but then you just have to keep up with the minus signs. So when you find tan inverse are negative, make sure between 0 and. But by the definition, it doesn't fall in the range now. Alpha is normally between 0 and 90. So that is the general solution. I could have changed the letter, you know, for sure. By the way, anybody seeing, if I ask you, what's the maximum value for this? I'm breaking some more voices. What do you think is the max value for this, or what is the minimum value for this? Anybody seeing it? What's the biggest value that could be? If you had to draw that graph, look at what you're comparing it to. Anybody online could guess? What do you think is the biggest value of a cos theta? Oh wait, Samira, now seen a question there. Did I answer it anyway? Samira? I didn't answer it? Okay. You could remind me where you asked that? The R always positive. How to get R? R is always positive, for sure. Square root of A squared plus B squared. Yeah. Anybody seen it? So if I But remember we said that this is equal to this, right? Yeah? So what's the largest value of cos theta? 1, correct? What's the largest value of cos theta plus alpha? Same one, right? What's the largest value of r cos theta plus alpha? R. You're seeing that? So the largest value for cos theta is 1. So r by that is makes it r, right? So the largest value for r, for maximum value for a cos theta minus b sine theta is r. And if you had to guess, what's the minimum value? Minus r. Okay? Do the same thing. Yeah, but think about it. When sine at max, cos at what? Right? So kind of in between. Right? Oh yeah, you'll have that, right? All right, well, let me try one. Ooh, no more slides. Anybody writing online? Nobody writing? All right. Last one here, taking off these slides and I'm putting a new one. Yeah, a little past. We reach past people. All right, so am I going to tell you? Nope. Solve 3 cos theta minus 4 sine theta is equal to 3. Try that. Any form you want. You can go back and use the list I gave you and figure it out. Take your time. Go back through the forms I gave you and try to work it out. It's almost is in every class you'll see one. Right? Which form you choose, Shivish? Which one? Huh? Which one of the forms are right? R what? R cos theta plus alpha. Okay. So it's fine R. It's fine R. Square root of that, right? Square root of 3 squared plus 4 squared. Also, if you're using Aaron, if you're using the R sine theta to work out anyone, you'd have to write 3 plus minus 4 squared. Right? Those little things you gotta pay attention. Here. You'll get the same answer, but you gotta do it that way. So that'll be 5, right? And then we want to get alpha. So let's just compare it quickly. 5 cos theta minus 4 sine theta equal to R cos theta cos alpha minus R sine theta sine alpha. Right? So we could compare and we'll get R cos alpha to be equal to 3. So alpha is equal to cos inverse 3 on 5, which is 0.927. 0.927. So therefore, what do we have now? We have 5 cos theta plus 0.927 equal to 3. Trying to get general solution, right? So that would be, by the way, if they don't say general solution, means that you just find the angles within the range, right? Like what we did last week. Okay? Find the angles within the range. So that will be cos theta plus 0.927 is equal to 3/5. So therefore, your general solution is theta plus 0.927 is cos inverse 3/5. Sorry, what am I? Yeah, right. So your general solution is theta plus 0.927 is equal to 2n pi plus or minus cos inverse 3/5 was what? I get back 3/5 again. 0.927. Correct? So that would be theta is equal to 2n pi plus and minus 0.927 minus 0.927. Right? So I got 0.927 twice. Okay? Malika, you okay with that? Are you okay with this here? Yeah? Quick question. What's the maximum value of 3 cos theta plus 4 sine theta? What's the maximum value of this? 5, right? Maximum value is R, which is 5, right? Just suppose, Janessa, suppose I didn't have 3 here and I had 7. What would happen to this question? Suppose instead of having 3, I had 7. What do you think would happen? What's the max value again? So I gave you a value bigger than 5. So what do you think would have happened to this whole solution? It wouldn't work out. You get invalid, right? You'll get invalid. Adrian, you okay with us? So next day, what we'll do is we'll do what the past papers asking us. The past papers like to ask us to put it in a form and then give the max value and give the minimum value. Almost every year you'll see that. Okay. So we'll do a couple of those, and then we have to look at the new identities for unit 1. Right? Not much.